Hi everyone. Now let us solve this game. So here this is the payoff matrix for the given game, and the strategies of player A, there are 4 strategies are there, and similarly for player B also there are 4 strategies are there. So the order of the payoff matrix we can say is 4 by 4. So now I want to solve this game. So I don't know whether this game is having a saddle point or not. If it is having a saddle point, then we can solve this game by one method, or if it is having no saddle point, then we can solve this game by another method. So first of all, let us check whether this game is having a saddle point or not. So I rewritten the game. So now we need to find the row minimum values. So now take the first row. What is the minimum value in first row? In 6, 2, 4, 8, minimum is 2. Similarly in second row, in 2, minus 1, 1, 12, minimum is minus 1. In third row, 2, 3, 3, 9, the minimum is 2. In fourth row, 5, 2, 6, 10, the minimum is 2. Now let us find the maximum value. So in row minimums, 2, minus 1, 2, 2, the maximum value is 2. So we are saying this value as maximum value. Similarly, let us find the column maximums. So what are the column maximum values? Now take the first column, 6, 2, 2, 5. The maximum value is 6. In second column, 2, minus 1, 3, 2. The maximum value is 3. In third column, 4, 1, 3, 6. The maximum value is 6. In fourth column, 8, 12, 9, 10. The maximum value is 12. So now what is the minimum value in these 4? 6, 3, 6, 12. The minimum value is 3. So we are saying this one as mini-max value. It has mini-max value. So now let us check whether max min and min max values are equal. No, 2 is not equals to 3. So that we can say that this game is not having a saddle point. So now we need to solve this game. So if the game is not having a saddle point, so then we can solve it by algebraic method, right? So how to solve it by algebraic method? The algebraic method is applicable only when there is presence of only payoff matrix of order 2 by 2. But here we are having the 4 by 4 matrix. So if it is 2 by 2 only, then we can able to solve by algebraic method. So how to convert a 4 by 4 matrix into a 2 by 2 matrix? We can convert this by dominance principle. So let us convert this 4 by 4 matrix into 2 by 2 matrix by dominance principle. So now let us see, verify the dominance. So first of all we need to check the row dominance. If row dominance is not worked out, then we have to verify the column dominance. So now compare the rows 1 and 2. Compare the rows 1 and 2 values. 6, 2. Row 1 is higher. 2, minus 1. Row 1 is higher. 4, 1. Row 1 is higher. 8, 12. Row 2 is higher. So row 1 is not completely dominating the row 2. So it is not a possible case. Now compare the row 1 and row 3 values. Now check 6, 2. Row 1 is higher. 2, 3. Row 3 is higher. So row 1 is not completely dominating row 3. So it is not a possible combination. Now take the rows 1 and 4. So now check the values. 6, 5. Row 1 is higher. 2, 2. Both are equal. It is also considerable. 4, 6. Row 4 is higher. So row 1 is not completely dominating row 4. It is also not a possible combination. Next, check the other combinations. Now I am taking rows 2 and 3. Now if you take 2 and 3, then compare the values. 2, 2, both are equal. Minus 1, 3, row 3 is higher. 1, 3, row 3 is higher. 12, 9, row 2 is higher. So row 2 is not completely dominating row 3. So it is not a possible combination. Now I am taking one more combination, 2, 4 rows. Now compare the values. 2, 5, row 4 is higher. Minus 1, 2, row 4 is higher. 1, 6, row 4 is higher. 12, 10, row 2 is higher. So row 2 is not completely dominating row 4. It is also not a possible combination. Now I am taking one more combination, 3, 4. So now check the values. 2, 5, row 4 is higher. 3, 2, row 3 is higher. So no row is not dominating another row. So it is also not a possible combination. So I have tried all combinations of player A in rows. So row dominance is not work out. Then let us see the column dominance. Now take the columns 1, 2. Now compare the values in columns 1 and 2. 6, 2, column 1 is higher. 2, minus 1, column 1 is higher. 2, 3, column 2 is higher. So column 1 is not completely dominating column 2. So it is not a possible combination. Now take the combination 1, 3. So if you take 1, 3, then compare the values in those columns. 6, 4, column 1 is higher. 2, 1, column 1 is higher. 2, 3, column 3 is higher. So the column 1 is not completely dominating column 3. So it is also not a possible combination of dominance. Next, take the columns 1 and 4. Then 1, 4 columns I am taking. Then check the values. 6, 8, column 4 is higher. 2, 12, column 4 is higher. 2, 9, column 4 is higher. 5, 10, column 4 is higher. So column 4 is completely dominating column 1. So column 4 is having higher values. So now eliminate column 4. So then what we can write? In player B only 1, 2, 3 columns. In player B I am writing only 1, 2, 3 columns. Right? Now write those values. Player A having 4 rows, but player B having only 3 columns. So 6, 2, 4, 2, minus 1, 1, 2, 3, 3, 5, 2, 6. So now this is the reduced payoff matrix. So how we got it means B1 is less than B4. So eliminate B4, right? Based upon this, we have written this reduced payoff matrix. Now let us go for next iteration. So next iteration. Now again check the row dominance in the reduced payoff matrix. Now I am taking the combination of rows 1 and 2. Check the combination values. 6, 2, row 1 is higher. 2, minus 1, row 1 is higher. 4, 1, row 1 is higher. So here row 1 is completely dominating row 2. So here row 1 values are higher, row 2 values are lower. So eliminate lower row as it is having lower values. So now the reduced payoff matrix is, we are eliminating row 2 here. So I am writing the player A strategies as 1, player 2 strategy 2 I am eliminating 3, 4. This is for player A. So for player B Already 1, 2, 3 are there. We are not eliminating any column. 1, 2, 3. So now write the values. First row 6, 2, 4. Third row 2, 3, 3. Fourth row 5, 2, 6. So now this is the reduced payoff matrix. So how this matrix came means, as row 1, that is A1, values are greater than A2. So that's why we have eliminated row 2, that is A2 strategy. So with the help of this, we got this reduced payoff matrix. Now let us go for next iteration. Again check for row dominance. So if you check the row dominance, now take the combination of 1 and 3. So if you take the combination of 1 and 3, compare 6, 2. Row 1 is higher, 2, 3. The strategy 3 is higher. So this row is higher. Here in this first row is higher. Here in this second row is higher. So it is not a possible combination. Now take strategy 1, strategy 4. Then compare 6, 5. First strategy is higher. 2, 2. Both are equal. 4, 6. Strategy 4 is higher. So none of the row is dominating another one. So it is not a possible combination. Then take the strategies 3, 4. Then compare 2, 5. Strategy 4 is higher. 3, 2. Strategy 3 is higher. So none of the row is not dominating another row. So it is also not a possible combination. Then go for column dominance, individual columns checking. Now I am taking the column 1, column 2. Check the values. 6, 2 is column 1 is higher. 2, 3 column 2 is higher. That is second strategy is higher. So it is none of the column is not dominating another column. So it is also not a possible combination. Next, now I am taking the strategies 1, 3 of player B. Then compare the values 6, 4. First strategy is higher. 2, 3. Third strategy is higher. 5, 6. Here also third strategy. So here first strategy. Here in these two cases third strategy. So none of the column is not dominating another one. So this combination of columns also not a possible case. Now I am taking the combination of 2, 3. Then compare the values 2, 4. Third strategy is higher. 3, 3. Both are equal. 2, 6. Then third strategy is higher. So if you take this case, then column 3 is completely dominating column 2. Then what the thing we have to do? The higher values of column has to be eliminated. So now write here B3 is greater than or equals to B2. So eliminate B3. So now what is the reduced payoff matrix? We are eliminating B3. So for player B, we are having only 2. 1, 2. And for player A, 1, 3, 4. Then write the payoff value 6, 2, 2, 3, 5, 2. So now this is the reduced payoff matrix. Right. Next, in order to solve it by algebraic method, we need to convert into 2 by 2. Until 2 by 2 we need to do. So now here it is a 3 by 2 matrix. We need to eliminate one more row. So now check the row dominance. So what is the row dominance? Take the 1, 3 rows. Then compare 6, 2. First strategy is higher. 2, 3. Third strategy is higher. So none of the row is not dominating another one. Not a possible combination. Then take 1, 4 strategies. Then compare the values. 6, 5. First strategy is higher. 2, 2. Both are equal. So here first strategy is completely dominating fourth strategy. So first row values are higher. So that's why the lower row values should be eliminated. So what we can write? A1 is greater than or equals to A4. So then what we can write? Eliminate A4. So now write the reduced payoff matrix. Player B 1, 2. Player A 1, 3. So the values are 6, 2, 2, 3. This is the payoff matrix. So the 4 by 4 matrix gets converted into 2 by 2 matrix. Okay. So now with the help of algebraic method we can able to solve this problem. So now let us do the things. Let us find the arguments for that. So the difference of 6 to 4, write it here. Difference of 2, 3, 1, write it here. Next, difference of 6 to 4, write it here. Difference of 2, 3, 1, write it here. So these are the arguments. These are all of arguments. Now let us find the probabilities of selecting the strategies 1, 3 by player A. Probabilities of selecting the strategies 1 and 2 by player B. So here we are writing for player A it is a first strategy. So I am taking it as Q1 is equals to. So for first strategy what is the argument? 1 by sum of argument is 1 plus 4. That equals to 1 by 5. So sorry, for player A it is P1. P1 is 1 by 5. Similarly, probability of selecting the third strategy. So we can take it as P2 is equals to. So this is for third strategy and this is for first strategy is equals to. What is the third strategy argument? 4 by sum of arguments is 1 plus 4 is equals to 4 by 5. So now write the overall for player A is probabilities of selecting this first strategy 1 by 5. Probability of selecting the second strategy. Here whether second strategy is there in 2 by 2? No. So we are not at all utilizing the second strategy. So we are writing it as 0. Comma. Probability of selecting the third strategy. So third strategy probability is nothing but 4 by 5. So in order to avoid confusion, here it is a third strategy. I am taking it as P3. Right? So that the confusion can be avoided. So for first strategy P1, for third strategy P3. Even though we are not having 2 by 2 matrix, as we are having the strategies, I am writing the suffixes with the help of the strategies. Right? Next, probability of selecting the fourth strategy. Whether in the reduced 2 by 2 matrix, whether fourth strategy is there? No fourth strategy. So that's why probability of selecting the fourth strategy is 0. So that is A, P1, P2, P3, P4. Right? So probability of selecting the first strategy is 20%. Probability of selecting the second strategy is 0%. Probability of selecting the third strategy is 80%. Probability of selecting the fourth strategy is 0%. So sum of probabilities will be 20% plus 80%, 100%. Right? So similar way, let us calculate the probability of selecting the strategies by player B. So for player B, we will take it as Q. So probability of selecting the first strategy, Q1, I am taking is equals to, so what is the first strategy augment? 1 by sum of strategy augments 1 plus 4. So I am writing it as 1 by 1 plus 4 is equals to 1 by 5. Similarly, so for player B, second strategy is available. So probability of selecting the second strategy. So the augment for second strategy is 4. So now take it as we are having the second strategy, I am mentioning it as Q2. So Q2 is equals to, what is the second strategy augment? 4. So 4 by sum of augments 1 plus 4. So 4 by 1 plus 4, that equals to 4 by 5. So if you write it in a consolidated way, probability of selecting the strategies by player B are Q1, Q2, Q3, Q4 are B of first strategy probability 1 by 5, second strategy probability 4 by 5, as third strategy and fourth strategy are eliminated, so the probability of selecting the third and fourth strategies are 0, 0. So in terms of percentages, if we say probability of selecting the first strategy by player B 20%, second strategy 4 by 5 means 80%, here it is 0%, 0%. So the sum of probabilities will be 20% and 80%, so 100% we got, right? And finally we need to find the value of the game. So value of the game is represented by V is equals to, how to find the value of the game? We know that 6 into 1 plus 2 into 4 by 1 plus 4. Now write it as 6 into 1 plus 2 into 4 by 1 plus 4, that equals to 6 into 1, 6 plus 2 into 4, 8 by 4 plus 1, 5. So that equals to 14 by 5. So this is the value of game. So as the value of the game we got it as positive, so we can say that the player A wins the game by 14 by 5 points. So like that we can able to solve the game theory problem if it is not having a saddle point with the help of combination of two methods, that is dominance principle and algebraic method, right? So I hope you understand this problem. If you understand it, please like the video and subscribe to the channel and share this video. Thank you.